Hello, this is the preliminary design review for the Project 10 team Hall Effect Thruster Visualization Project. I'm Brian Culver. The Psyche mission is going to send an orbiter to an asteroid between Mars and Jupiter, which is believed to be the core of a planetesimal that was formed in the early stages of our solar system's history. The Psyche orbiter will be the first spacecraft to leave Earth orbit equipped with 4 Hall effect thrusters, typically referred to as Hall thrusters. This method of space propulsion is significantly different from traditional chemical propellants, and most of the general public knows very little about how these engines operate. Our team is tasked with creating an interactive visualization of the Hall thruster to educate the general public. Our visualization tool should be as entertaining and as interactive as possible to maximize the potential audience impact. Our deliverables will focus on imagery of the Hall thruster and its components, a valuable user experience, accuracy of the design, and education value. The graph shown here demonstrates the impulse per unit mass of fuel delivered with chemical rockets in red, as compared with the new electric propulsion system used by the Hall thruster in blue. We will depict Hall thruster benefits, explaining how, with greater velocity per atom, the fuel in a Hall thruster will be much more efficient and provide more total thrust over the voyage of the spacecraft. Chemical rockets provide large, concentrated thrust in a short amount of time, but are not as efficient as Hall thrusters at low thrust levels.
This project was designed to be a single-page web application written in React, which is a front-end JavaScript framework, which will be continuously integrated using Travis CI and hosted on a web DigitalOcean droplet with an Apache web server. And the reason for all of these design choices is to provide an interactive and user-centric front end. The reason for the choice of React was the great support in the community, as it is the most popular JavaScript front-end framework today. And DigitalOcean gives us great flexibility in terms of the hosting power that we need and the fastest deploy times. The goal here is to provide a server-rendered application as opposed to just serving the client simple HTML and CSS web pages that they have to interact with in the same way that they would any website. Instead, we are going for more of a web application sort of feel, which is greatly more interactive. It'll be more similar to a desktop application as opposed to a website.
Our implementation strategy for this project will be to follow an evolutionary prototyping lifecycle. So starting with the initial design, we will add features and functionality with every sprint. The initial design is just a simple web page with an image of the orbiter and a little bit of text. This is basically to test that the React portion of the product is functioning properly with the basic HTML elements, and we're going to use this to ensure functionality across multiple browsers. After that, each scrum is going to be focused on a single component of the orbiter, so creating the asset, embedding it, and adding the functionality to make it interactive. Alternatively, if we can get access to pre-existing images of the orbiter, we can use those rather than creating them from scratch. References for the details of the orbiter, the technical details, are mostly going to come from presentations to the International Electric Propulsion Conference and from publications by JPL, all of which were shared by our project sponsor. Image references will come from official NASA and ASU websites, social media, and publications. Full bibliography of reference sources can be found in the project plan document. After all the components have been added to the web page, our sprints will shift focus to more stylistic changes to the web page, as well as adding other useful functionalities such as links to external sources and other general information about the mission. In order to ensure a consistent environment, all of the team members will be using the WebStorm IDE. JavaScript is a new language to most of us, so working in the same environment will be key in ensuring cohesion and consistency across the whole project. It also means we'll be more equipped to help each other when we run into any issues. Quality policies and documentation will be done by Tega, and version control will be done with GitHub. Each user story will be white box tested by the developer responsible for that user story, and then black box tested by at least one other developer before it can be merged back into the master branch. We will continue this iterative process, adding functionality until we have a fully interactive visualization of the Hall effect thruster.
Agile Scrum will be used since its advantages fit the flexible nature of our project. This will allow the project to move forward iteratively so requirements can be easily added as they come up. Sprints will be conducted in 12-day intervals starting on Wednesdays. We will have 2 days in between sprints for requirements review, sprint retrospective, and building backlog. This will coincide with our bi-monthly sponsor meetings, giving the sponsor time to review each new revision and provide feedback to promote elicitation of more specific requirements. No specific development tools were given by the sponsor with the exception of River, which will be used for communication between the sponsor and the team. Taiga will be used for process management, project tracking, and requirements logging. User stories will be added to the sprint backlog based on the schedule outlined previously. GitHub will be our project code repository and revision control program. Each branch will relate to a user story in Taiga with the same number. WebStorm will be used as a common IDE for JavaScript using React. React is a JavaScript library that will provide a dynamic view of the visualization we hope to create. Google Chrome, along with other internet browsers, will be used for testing and verification. Team members will have one of 3 roles per sprint: Scrum Master, Git Master, and Developer. After each sprint, roles will be rotated such that each team member will have the opportunity to contribute at each position. The Scrum Master will be responsible for maintaining the Taiga page, ensuring the Scrum process is followed. The Git Master will control the branch merges to ensure quality assurance guidelines are adhered to. Each developer will assign themselves 1 to 2 tasks at a time during a sprint until they are tested and closed before assigning new ones. Testing must be verified by at least 2 team members prior to merging to the dev branch.
This is Julio Jovel here to talk about risk management. Our first risk identified is bugs in transition. Transitioning to a final web domain can introduce bugs that we hadn't seen while developing. We've asked our sponsor to see if they have a domain ready for us or if we need to look at cloud services ourselves. Our second one is conflict resolution. The team works around the United States in different time zones with different backgrounds, and that can bring about some conflicts while trying to work on different parts of the project. We've asked the team to make sure that they choose to focus on exercising patience and good judgment when making any calls. Our next one is large tasks and small victories. Large tasks can be burdensome, can take long times, and so we invite every team member to break down these tasks into smaller, more manageable ones. The focus of smaller victories can keep us moving forward and allow us to have iterations that continue to be functional for the sponsor. Our next one is experience and timeline estimates. This project has brought about a new language for all the developers, which is JavaScript. We want to make sure that we give everyone enough time to learn and refine while working on the project. That being said, the initial task given will be smaller so that we have the time to learn, refine, and still have a functional product for our sponsor. Our final one is requirements and final design. The requirements initially are loose and open-ended, and they may shift in focus or implementation as we work through the project. While this is always bound to happen, the team has chosen to have a solid purpose and overall vision for the project in order to make sure that we always have something functional.